Thanks everyone for attending this session. Even if you do it live or afterwards, thank you so much for watching. My name is Adrian Gospaczewski. I'm developer relations at Vision, the DevOps company. I speak to you with Sergio Nuzzo and Arno Aukia, who are my colleagues. They are here in the call as well. And of course, very glad to answer your questions during this day. I'm speaking to you from the beautiful city of Switzerland, of Zurich in Switzerland. It's a bit rainy day today, but it's still a very beautiful city. And just a few words about Vision, just to set a little bit the stage of what we do and what is our specialty. First of all, how do you pronounce the name? That's a very good tip. It's pronounced like Vision, like the eye, hence the logo. And we've been in Zurich for already 7 years. Since 2014, we are the DevOps company. We are 42 Visioneers, and we are the leading DevOps and Kubernetes partner in Switzerland, providing 24/7 support for companies all over the country and abroad, thanks to the fact that we are certified ISO 27001, and we've got the ISA 3402 report verified as well. That allows us to work as well in various industries that require high level of privacy and security in their operations. And first of all, and very important, we've been the first company in Switzerland to be certified Kubernetes, officially certified by Google, to provide Kubernetes services. We've got a huge array of partners, but of course, Exoscale is one of the most important partners we have, and we use their services a lot. And of course, we are partners with many other industry players in the industry, like Red Hat, Rancher, Crossplane, Docker, Nginx, and GitLab, and many, many others. But these are right now the most important. And given the work that we do, we've developed our own products that we offer as well to our customers. So for example, we have a PaaS, a platform as a service called Apuyo that we have based on top of Rancher and OpenShift, and we offer to our customers. And we have developed two very big and very important open source projects called Project Sin and KTOP, both targeted specifically for Kubernetes. But I'm going to go back to Kubernetes in a while. For a moment, I'm going to give you a little bit of an agenda of what's going to be, what are we going to talk about here today. First of all, I want to give a quick overview of what's going on in the cloud, about cloud services today, just a little bit of vocabulary and just a little bit of context. So first of all, we are going to talk about DevOps. We're going to talk about what is the cloud infrastructure that you can usually use on the cloud these days. We're going to talk about Kubernetes. We're going to talk about infrastructure as code. And we're going to have a live demo. All of that in 30 minutes. So I hope you're ready, because there's a lot of information. And of course, feel free to post your question and answers directly on the chat. My colleagues Sergio and Arno will be very happy to provide answers as we go. Okay? Very good. So let's get started. First of all, we talk about DevOps a lot these days. So DevOps is a moniker that, of course, merges development and operations of applications. So not only creating them, but actually putting them into production and making sure that they run properly. And DevOps builds on top of several technologies, like, for example, continuous integration and deployment, version control. But those are the technical parts. On the human side, DevOps is based on agile collaboration. We use agile principles to collaborate better as a team when we use DevOps. And of course, we use infrastructure as code, which is something that we're going to talk to today, in order to be able to deploy our applications on the cloud. And of course, we couple all of these with automation. This allows teams to become very good at repeating things, at being able to guarantee certain levels of availability and services on the cloud, thanks to automation. The second thing we're going to talk about today is cloud infrastructure. When we talk about the cloud, what are the things that we usually talk about? Well, it basically boils down to three major building bricks, right? The first building brick is compute. We want to run our payloads on the cloud. So we have compute services on the cloud. We have storage services, of course, because we generate data sets. Typically in research, you run a program, you run a simulation, you're going to have plenty of data coming out. You have to store that somewhere in order to analyze and to see which were your results. And of course, you need security. These are the three main building blocks of any cloud provider. And you can look at various cloud providers. You're going to find pretty much the same three bricks all over the place. However, what we offer together with Exoscale is much more than that, because of course Exoscale gives you compute, storage, and security services. That's a given. You're going to see it because I'm going to show you the Exoscale console in a few minutes. So you're going to see exactly how that works. But Exoscale also offers a managed Kubernetes service that I'm going to use during the demo as well, which provides in a very, very short amount of time a ready-to-use Kubernetes cluster for your payloads to run on. And it offers great availability, very high availability, and the most important feature, in our opinion, is the cost visibility. It's very easy to know where you are in terms of the costs of those storage, compute, and security services that you are paying for. And this is not always the case with many cloud providers. And then we come into the picture, Vision, together with Exoscale. What we can provide the fact that we are a certified Kubernetes service provider. We've been doing this since 2015, 2016, when the Kubernetes was very, very early in its development. We have radical transparency for ourselves and for our customers. We provide 24/7 support. We are there in any problem you might have in any situation. And actually, many times you don't even realize, our customers don't even realize that we are monitoring their systems 24/7, because we take care of issues before they even happen to them. We take care of backups. We take care of the redundancy of their systems. And they don't even notice. Things just work. So that's exactly the goal that we are trying to reach with Vision. And of course, security, for us, it's a must. And we provide not only security guidance for the development teams, we also ensure that all of the payloads managed by Vision are consistently applying the best practices provided by standards like the ISO standard that I mentioned earlier. Exoscale is incredible. It has data centers all over Europe, and it's all interconnected with Xeon. So you are never very far away, not even more than a few milliseconds away from the closest Exoscale region. So this is a fantastic partner to build upon. And this is how, together with Exoscale, we can offer plenty of services. First of all, thanks to Exoscale, we have compute, network, storage, and security services in various locations: Frankfurt, Munich, Vienna, Geneva, Zurich, and even Sofia in Bulgaria. And those provide, all those data centers provide guaranteed data location. Thanks to Kubernetes, we can offer several different packages. You can run, of course, your payloads on the standard and on the scalable Kubernetes services offered by Exoscale, which is a very, very recent service created by Exoscale very recently, but very, very solid and very powerful. But you can also have Red Hat OpenShift. If you are using OpenShift and you would like to run your payloads in OpenShift, we can do that as well on Exoscale, as well as Rancher, which is one of the most popular choices for many, many teams all over the world. Database as a service, in terms of storing your data for whatever payload you are creating, whatever data that you are managing, we can manage pretty much any database, and Exoscale can run any database that you need. MySQL, MariaDB, Postgre, Mongo, you name it. We can run it on Exoscale, and Vision can manage it for you. Of course, we've got a lot of offerings towards software as a service. Do you need GitLab? Do you need Nginx? Do you need Keycloak? No problem. We can install that and run that for you 24/7. And of course, thanks to all the experience of Vision, we've been doing this for years, and we can offer you all of this experience together with your application. Basically, Exoscale is the default choice for institutions of all kinds handling sensitive data. And if you are looking for reliable and secure cloud providers outside of the big three, which I will not name. So basically, Exoscale is a Swiss company that is part of Telekom Austria, from A1 Telekom Austria Group. So it's 100% European. They are also certified 27001 and 27018 certified. Again, audit report available 3402, GDPR compliant, and already used by government, banking, health, medical, and education and research. And of course, together with Vision, we can offer 24/7 support available, but Exoscale as well, they provide their own, for their own infrastructure, the support that is required. But don't let me tell you anything about Exoscale and Vision. Actually, you can start asking names like CERN, Switch, the Swiss Federal Archives, or many other companies. There are already organizations as well, governmental organizations and private companies that are using our services and are running their applications 24/7 with all trust and guarantee. The third thing I want to mention today is Kubernetes. You're going to hear the name Kubernetes a lot. Kubernetes is kind of the default operating system for your cloud applications. These days, the cloud industry has chosen Kubernetes as the basis, as the de facto platform. And you can have Kubernetes applications running on top of Exoscale SKS, on top of any cloud provider, but also in your own premises. So whenever you deploy an application on Kubernetes, you might as well be running it on your own laptop if you want, because Kubernetes provides that kind of portability so that your applications can run on different environments and they basically are completely oblivious, but they just run. So this is great for development teams, for operations, for debugging, for quality purposes, and so on. The fourth thing that I want to mention today is infrastructure as code. What is this thing is infrastructure? So let's go a step back in time and see how the web has evolved. So first of all, in the 1990s, there were very few users. And I remember, because I started my career in 1996, we had basically one web server and one database server. They actually had names. So it was very cute because you gave names to those servers. If you were a Star Wars fan, they would be, Alderaan, Hoth, other planets from the Star Wars universe. If you were a Lord of the Rings fan, you might want to use other names, but you get the idea. It was very, very low requirements for teams. So you could have maybe one or two people taking care of this, a couple of scripts here and there, and boom, you've got your servers. In the 2000s, things started picking up steam. Why? Because basically the web was becoming extremely popular. More and more services were going on the web. And thanks to projects like Nginx, teams were starting to do load balancing. So you could have several instances of your app and you would have these instances replying to a service. And basically, you had to manage manually all of these servers. You had to spin up the virtual machines or the hardware machines in some cases, unfortunately, that's also happened, and then connect them and wire them together and connect the networking and the firewalls and make all of these operations manually. It was very tedious. And the thing is that in the past decade, this has become extremely complex. You cannot manage these anymore in artisanal ways. So you have now lots of load balancers and lots of services and lots of boxes running your code in several instances, talking to different databases. You have to coordinate all of those efforts. It becomes quickly very, very complicated to actually understand what's going on. So that's why we haven't developed, we would be really happy if we did it, but there's a tool called Terraform, which has become the standard for infrastructure as code. And Terraform, as shown on the slide, basically Terraform allows you to describe the things that you need in your infrastructure, how many servers, how many load balancers, which security policies, and then you can put that file inside of a project. Other teams can share it, other teams can contribute to it, other teams can understand very clearly what's going on. And this infrastructure as code allows teams to move faster and to basically have their applications running on the cloud in no time. And to demonstrate all of this, because there's a lot of concepts that I've mentioned in this very short 15 minutes, so I'm going to do a very short demonstration in which I'm going to create a Kubernetes cluster on Exoscale using Terraform. I'm going to deploy an application live on that cluster using Kubernetes. So this application will be running in Kubernetes. And then I'm going to scale this application horizontally because I'm going to tell you a secret. Unfortunately, this application is kind of, let's say, legacy. It's not very fast. It runs a bit slow. So in terms of making a better user experience, I'm going to create several, we're going to have several instances of this application behind the load balancer so that things go a bit faster for our customers, because we have to also take care of the legacy code that we have running. And Kubernetes is very good at that. We can actually have our code running in very, very beautiful ways using the tools that we know. And this is what I'm going to show right now. So I'm going to pick up my mouse. And here we are. First of all, I wanted to show you, I have here the Exoscale console. I'm connected with a demo account. And here, as you can see, once again, the major building blocks of all cloud services: compute services, storage services, and security services. And this is fantastic. This is exactly a very simple way to understand what's going on in your cloud. So here, I'm not going to use storage or security for this demo. The only thing I'm going to use is compute services. And in particular, what I'm interested in is this little entry right here, which is SKS, the Scalable Kubernetes Service by Exoscale. So as you can see, I have nothing in this. This whole thing is completely empty. I don't have a cluster. I don't have a Kubernetes cluster. I don't have instances. So the instances are literally virtual machines running, for example, Linux or Windows that you have in your environment. So I don't have anything. This is a completely clean account without anything in it. So that's great. I'm going to make this window on the side. And here I have the dreaded and the all-powerful command line that technical people are very, very happy to use because it gives them the full power to execute stuff on the internet. So this is how, you know, things break sometimes, but in this case, we're going to create things, which is much better. And I'm going to use a tool called Terraform. Terraform is basically a tool. It's an executable that you could have in the program files of your Windows application, for example, in your Windows operating system, right? And I can see that in this location, I have an SKS cluster.tf, tf meaning Terraform, SKS cluster.terraform file. And this describes a Kubernetes cluster. This Kubernetes cluster is in the Geneva region. I like Geneva because I am from Geneva. You know, in Switzerland, we've got this concept of the cantonal nationality, and I am a Geneva person. Je suis Genevois. Alors, I'm very happy to put my cluster in Geneva for this demo. And what do I have in this cluster? Well, very simply, the most important thing that any cluster has to have is a name. So I will call it demo, not a very imaginative name, but it works. And I'm going to use Kubernetes version 1.21, the latest, one of the latest versions of Kubernetes that you can find. So we're on the bleeding edge of technology right here. So of course I can define a cluster. This is an SKS cluster. I'm defining security groups. These define who can talk to whom in this thing. And if I scroll down, I have here my node pool being the workers. These are the virtual machines that are actually executing your code when you deploy it on the cluster. So this is great. I have all of this infrastructure ready to go. So the first thing I can do is to ask Terraform for a plan. Terraform plan basically will connect to Exoscale, verify that I have a connection, that everything is working. And if I scroll up, I see that this plus sign means that things are going to be created. I'm going to create a node pool. I'm going to create a security group, and so on and so on and so forth. That's great. So that means that everything works, everything is green. So that means that I can Terraform apply. And this is in real time. I'm actually typing this as I go. So I hope the demo gods will be good to me. Terraform apply. And I have to confirm. Of course, you have to confirm because it's a potentially very big operation. So I'm going to write yes. And I'm going to wait. And this should take between 1 minute and 10 seconds to around 2 minutes, 20 seconds. The various times that I've tried this demo, sometimes it gets faster, sometimes not. The first thing I'm going to see is in SKS, boom, I have my demo cluster. My demo cluster demo is creating. This is really good. So I'm going to see now in my instances, so it's been what, 20 seconds now, okay, maybe 30 seconds. In a few seconds, we're going to see something more interesting happening. But this is all, basically what I'm telling Terraform to do is, please take this description of a system and make it happen. I really don't know exactly how Exoscale works internally, but I don't need to. And this is great because this knowledge of Terraform actually works pretty much with pretty much every cloud provider on the planet. So knowing Terraform opens the door to your team to operate on any cloud provider that you might find anywhere. So this is fantastic knowledge, and this is a great tool. And of course, Exoscale is 100% compatible with it. So now we've been 1 minute 10. Let's see if in a few seconds we have something happening on the screen right here, maybe 120. Last time I tried was 115, but it depends sometimes. So there we go. We are creating the workers. And there we go. We've got all of our instances. We have 3 virtual machines that are actually fulfilling the roles that we've specified in our Terraform definition. This is fantastic. Of course, I could do Terraform destroy right now, which is the exact opposite command. I'm not going to do that because I need this cluster as we speak. So that's okay. We can do this right now. I'm going to go to the second window right here. And on the window above, I'm going to type commands. And on the window below, I'm going to show, in this window below, I'm going to show the status of my system as it evolves. I'm going to take a little bit of water. Much better. So the first thing I need is to get from Exoscale the security information so that I can access my cluster. And for that, thankfully, there's a very useful command provided by Exoscale, which is Exo. It's called Exo. It's the official tool provided by Exoscale that allows DevOps operators to create and destroy elements manually on the Exoscale infrastructure. Of course, we are not using it for that purpose. In this case, the only command I'm going to type today in the Exo command, which contains lots of options. As you can see, it's the Exo SKS. So I'm talking to Exoscale, but specifically to the scalable Kubernetes service. And I'm asking for the kubeconfig. The kubeconfig is the configuration of the Kubernetes cluster. It's literally that. It's a small piece of text that I will store locally on my machine that allows me to talk to Kubernetes, which is inside of Exoscale. So I'm kind of bypassing a little bit the Exo tool. So doing this, a few seconds later, I have exactly what I need. And now I can use that configuration, for example, with the K9S tool. And the K9S tool is a command line tool that allows me to see in real time what's going on inside of my Kubernetes cluster. So it's very convenient because it basically looks like this. I will hide the copyright information, and I can see the pods that are running. And pods are basically small virtual machines that are running inside of Kubernetes. You don't need to know much more what it is. It's one of the basic components of Kubernetes. What we are going to do now is to put our own pod inside of it. Very good. So the first thing I need to do is to create a namespace. So namespaces are very simple things. It's like a small project where it's like a sandbox where I can create my own objects inside and my own pods as well. So in this case, I'm going to see all the namespaces right here. And here I'm typing the command kubectl, passing the configuration that I just created in the previous command. I will create a namespace. I will create a namespace called heavy fortune. So if I do this, I see now right here, I have my namespace heavy fortune, and it's ready to use. I can hit enter, and I can see that it is empty. I have nothing in it. It's just like a shell, a virtual shell inside of my cluster. I will apply something else. Now, for a moment, I'm not going to do this. And right now, what I'm going to do is to create an alias, because otherwise the commands will become very, very big. kubectl, by the way, I haven't introduced kubectl, by the way. kubectl is the default tool that you use to talk to Kubernetes, any Kubernetes, wherever in the world, even if you're in your own machine. And kubectl allows you to perform operations on your cluster, okay? And basically, of course, I'm passing the kubeconfig security information that I got from Exo, and I'm only going to perform operations in the namespace that I just created, which is this little project called Heavy Fortune. Very good. So I have created this alias, and now I can apply an application. So what does this mean? First of all, kubectl apply takes the information of a deployment file into your Kubernetes cluster. What are these Kubernetes files? Let's take a look at it. If I do bat deployment YAML. So this is what it looks like. These are files that you can store together with your Terraform infrastructure that allows DevOps teams to collaborate with one another. And this one specifically explains that I'm running a container named Quay.io. Quay.io, it's a container repository created by Red Hat. I have my own account called Acosma. This is usually the nickname that I use online. And the application itself is inside of this container called Heavy Fortune. And I'm exposing this application on the port 1990. So basically, that's what I want right now. I'm going to apply deployment YAML. And look at what happened below. I have now a pod running on my namespace called Fortune deployment. This is really great, but I cannot access it right now from the internet, right? Because basically by default, Kubernetes will not expose to the outer world whatever you're running inside of your cluster for security reasons. This is not the default. So you have to expose things to the world. And how do you do that? You do that through a service. And I have a service here, it's the Fortune service, and the Fortune service talks to the Fortune application. And it's a load balancer type of object that will expose the application on port 3000. This is basically basic networking concepts, but very common, and I'm pretty sure your technical teams know exactly what's going on here. So this is what I'm going to do now. We're going to apply the service. So basically now if I go in K9S, if I select my services, I can see that I have a Fortune service and it is pending an external IP. I need to be able to talk to the service from the outer internet. So that will take a few seconds. And I'm going to have at the end, there we go, an external IP 194.182.160.233. What does this mean? Well, basically, I will run this command. Basically, what's going on in what you see right now is I'm going to grab the IP address that you see below so that I can talk to the service. So, for example, if I do echo, you can see it's exactly the same. This variable has exactly the same value as the one below because it's the external IP. And now what I can do is to open up a browser window. I can just HTTP 194.182.160.233 port 3000, because that's the port that I've shown in the service. And if I hit enter, here I have the Fortune cookie of the day running on Exoscale. And this is live, this is happening right now. And basically this service, you can refresh it and you get a new cookie of the day. And as you can see, it can take a while. It's not the fastest application in the world, right? Look at this, executed in 1.46 seconds, like seriously, to get some text and some random number. And this one is taking a bit longer than expected. You can see it's kind of suffering. It's not really liking it, but this is in purpose. I've done this application, I've changed this application so that it basically performs a lot of square roots, which are completely not needed, but it's just for the purpose of making things slower. There we go. I hit enter again. This one took 180. This one took 0.61. So as you can see, the duration, that's 143. 1 second, 0.43 in computer time is huge. We don't want to have this kind of performance. So what I'm going to do is basically, I'm going to kubectl kubeconfig. I'm going to apply a file called metrics server. This is something that is required for autoscaling by Kubernetes. And now I am going to apply an autoscale information. What is this autoscale information? Let's take a look at it. Deployment autoscale. Here, it's a very simple instruction. I'm telling Kubernetes to please go from 1 to 30 replicas of this pod, of this little virtual machine inside of Kubernetes, in case there's a need for more instances using it, right? So basically what I'm going to do now is Okay, apply. And I'm going to apply the autoscale. I'm going to apply the autoscale. There we go. So now, for those of you who are online, if you would like to play with me, you can just take the URL that is right here and start refreshing the screen. And I'm going to do the same here on the command line. I can access this web service from the command line as well. And as you can see, it takes a while to respond.
So I'm very sorry to disturb you a bit, but you have just hit the 30 minutes mark, so you should be coming to a close.
Yes, I am coming to a close, actually. What I wanted to show is to see things going up here, but it will take a while. So I will wrap up very quickly, and I leave this on the side running because I'm actually at the end of the presentation. So as a summary, DevOps, thanks to infrastructure as code, allows you to have a standard way to manage cloud infrastructure for your teams. Kubernetes is the standard for cloud applications, and Terraform is the standard way to create infrastructure as code in any cloud platform. Exoscale is, in our opinion, the standard cloud platform for cost and privacy-savvy teams. And of course, Vision, we are the standard choice for managing cloud applications wherever they are, particularly when they are in Exoscale. So we would like to ask all of you who watched this video, or who were live here with us, to try a trial voucher directly in vision.ch/OCRE. And as well, we provide training sessions. If you need more information about all of these concepts, we can provide that for you. And in our YouTube channel, vision.tv, we have plenty of information you can peruse and learn from it. And please feel free to download the slides of this presentation that you just saw at the bit.ly URL that you see on the screen. And having said that, thank you so much for your attention. And of course, if you have any questions, I will be happy to answer.